Hi everyone. Now let's start new unit number 3, sequence and series, lecture number 1. So first, what is mean by sequence? An infinite sequence of real numbers is a list of real numbers. Okay, a1 is the first number, a2 is the second number, a3 is the third number, third real number, up to so on. An is the nth real number, and up to so on. Why I'm writing up to so on? Because I said here infinite sequence of real numbers. How many numbers are there? Infinite number. That's why dot 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 I kept. So this is nth number in that collection. Okay, this is third number in that collection. This is second number in that collection. Okay, in a definite order. So this is not as what you want. In some particular order, we have to write all these numbers according to a definite rule. According to some rule, you have to arrange these numbers. What is meant by this rule and what is meant by this order? You will get into know very soon. Each number in this infinite sequence is called a term. So a1 is called the first term, a2 is called the second term, a3 is called third term, like that. So each number is called a term. Okay, and an is called the nth term. So this an, this one is called nth term. Okay. The suffix n is called the index of an. So this is called index. So what is the index of this term? 3 is the index. That means third term. This is second term. So 2 is index of this term. Okay, where occurs in this list. So now let us have the formal definition. What is infinite sequence? An infinite sequence of real numbers is a function a from natural number set to real number system. See, this is just look at like for example, you know already some functions like for example, f is a function from natural number set to real number system. For example, assume this is a function, and how it is defined? It is defined like this: f of x is equal to some x square. Okay, f of x is equal to some x square. So this is a function definition. Okay, now, so what is this n? So this n is domain, right? Natural number set is domain. That means whatever the inputs you are taking, so x is the input. X has to come from natural number set n. Okay, and this x square is belongs to codomain R. Okay, now let us choose a number 1. So natural number set, I'm choosing 1. So 1 is the input. If you give input 1, you will get 1 square is 1. So 1 is output. So this 1 belongs to real number system, like this. So similarly, what is f of 2? So f of 2 is 2 square. Okay, which is 4. So 2 is the input, which is from natural number set, and 4 is output. This is from real number system. So natural number set to real number system means input values from natural numbers and output values are real numbers. In the same way, instead of f, I am taking a function a. Now this f is function name. Now a is my function name. How it is defined? Natural number set to real number system. That means all the inputs coming from natural number set and outputs are belongs to real number system. Okay, that's what here I am telling. An infinite sequence of real numbers. Okay, outputs are all real numbers. How it is defined now? Look at the infinite sequence defined by the above function is denoted by an or sequence an. N is running from 1 to infinity. You can call this one as n is running from 1 to infinity. This n is what is this n? N is called index. N is running from 1 to infinity. Where an means what? This term. Look at your function an. This an, where an is equal to a of n. N belongs to natural number set. Like, see for example, so function is this and function name is an is equal to a of n. So if we take, look at here clearly, so an is a function. This is from where to where, or simply write a is a function from where to where, natural number set to real number system. Okay, now an is defined as a of n. So if we take n is equal to 1, what happens here? A1, right? A1 means a of 1. 1 is input, then you get a1. A1 means first term of the sequence. Similarly, if n is equal to 2, what you will get? If n is equal to 2, a2 I will get. a2, which is nothing but a of 2. Okay. Substitute 2 in the function, you will get a2. This is second term of the sequence. If you substitute 3, n is equal to 3, what is n? N is coming from n is coming from where? From natural number set. That's why n is 1, n is 2, n is 3, like that. So now if you substitute n is 3, you will get a3. a3 is nothing but a of 3, like this. This is function name, okay, where n is coming from natural number set. From now onwards, a sequence means an infinite sequence of real numbers. Okay, just I will call sequence only. It means infinite sequence of real numbers. You have to assume. Let us go with some examples. So first one, an is equals to 1 by n. That means the sequence an. So it means, listen carefully. You have to understand the symbolic forms carefully. Then will you understand clearly. See, it means like this. So an is nothing but 1 by n. This is nth term. Look at here. So this is an, right? This is nth term of the sequence. That's what I said here. This is nth term. Okay. Now this nth term of the sequence is 1 by n. That means instead of an, you denote like this. So now overall the sequence can be denoted like this. Look at here. an or an from n to infinity. Here an from n is running from 1 to infinity. You can represent like this the given sequence. So therefore the sequence I am representing like this. Okay. Now if you want, you can write n is from 1 to infinity, or simply you can write like this only, no problem. An simply. Now what is this? This is equals to, yeah. So before entering to that, now you write what is mean by this. N is running from where to when? 1 to infinity. So now here, substitute n is 1 now. N is 1, you will get a1. So this is first term of the sequence. Now n is equal to 2, you will get a2. This is second term of the sequence. Now n is equal to 3, a3. Now n is equal to 4, a4. Like that up to so on. Nth term is an and up to so on. How many terms are there? Infinity many terms. Here n is running from 1 to infinity. Similarly here, now let us run this. Now n is equal to 1. Run the sequence. If n is equal to 1, substitute here. Instead of n, you substitute 1. So we will get 1 by 1, right? So 1 by 1. This is the first term of the sequence, which is nothing but this is a1. Okay. Now n is equal to 2, 1 by 2. This is second term of the sequence. N is equal to 3, 1 by 3. This is third term of the sequence. N is equal to 4, 1 by 4. N is equal to 5, 1 by 5. Like this. Okay. And up to so on. Okay. Now in this, so this one is called, this is first term a1. What is this? The 1 by 2 is second term a2. And 1 by 3 is third term like this. So 1 by 4 is fourth term like this. And 1 by 5, fifth term like this. That's what you look at now definition. A is a function from natural number set to real number system. Inputs are from natural number set. Outputs are real numbers. Now look at input is what? In the sequence, input is n is equal to 1. If you substitute n is equal to 1, now n is equal to 1 is natural number. 1 is natural number. Then what are you getting? 1 by 1. So 1 by 1 is real number. Output. This is output. Now what is input? N is equal to 2. Substitute 2 here. So n is 2. 2 is real natural number. Input is natural number. Now what is output? N is 2. 1 by 2. 1 by 2 is output. Output is real number. 1 by 2 is a real number. It is not natural number, real number. That's why inputs are natural numbers, outputs are real numbers. Now n is 3, input. Give the input 1 by 3. 1 by 3 is output. So real number, likewise. So therefore, sequence is a function from natural number set to real number system. So this is first example. Similarly, second example. Look at this. Here, so now how to represent this? So sequence bn. So every sequence you can write like this in flower brackets. You can write like this, or simply you can write like this also. Okay, n is running from 1 to infinity. You can write like this also, no problem. You can write like this or like this, your wish. So let me write bn sequence bn, which is sequence. Now what is nth term? Minus 1 raise n upon n. Okay, now here, yeah, now let us run the sequence. What are the terms of this sequence? Substitute n is 1 now. N is 1. So minus 1 whole to the power of 1 is minus 1 only. Minus 1 divided by n is 1. This is first term of the sequence. What is second term? Substitute n is 2. N is 2, numerator is positive 1 and denominator is 2. Now n is equal to 3, numerator is negative 1 and denominator is 3. Now n is 4, 1 by 4. Now substitute n is equal to 5 minus 1 by 5 and up to so on like this. So this is a sequence. So this is like A1, okay. So this is A1, sorry, B1, because sequence is Bn, right? This is B1, this is B2, and this is B3, third term of the sequence, and this is fourth term of the sequence, and this is fifth term of the sequence. So like this we can construct the terms of the sequence. Now in this, you look at the definition there. What is the definition? I am going back. Look at here what I have written. Look at an infinite sequence of real numbers is a list of real numbers, all this in a definite order. Look at particular order we are maintaining and formed according to a definite rule. So here rule I want to, here what is the rule now? Rule is 1 by n. So this is the rule. According to this rule we are constructing these numbers. Okay, and we are arranging in some particular order. What is that order here? Look at order, right? So here order means first n is equal to 1 term, next n is equal to 2 term, next n is equal to 3 term, that means the third term, fourth term, like that. In this is called order. And what is rule here? Rule is nothing but 1 by n. This is a rule. According to this rule, these terms are arranged. I hope you understood. Similarly here, what is the order now? First term, second term, third term, that is order. What is the rule now? Rule is this, minus 1 whole to the power of n by n. So these terms are constructed according to this rule. Compulsory rule should be required. If rule is not there, I cannot construct these terms. So for every sequence, rule compulsory required. Rule or formula, whatever. Okay. Now let us have the third example. In this example, now let us construct. So this one I can write as sequence Cn, small letters you would write. Then according to this, how to write this? So this I cannot because it is taking two terms. So directly I can write. If it is only one order, one formula, I can write like this. Here formula is only one, minus 1 whole to the power of n by n, minus 1 whole to the power of n by n. But here two formulas are there. So like this in flower bracket I cannot write. Okay, two I cannot write. So therefore simply I can write like this. So therefore, now n is equal to 1. Substitute here C1, n is equal to 2, C2, n is equal to 3, C3, n is equal to 4, C4, and up to so on. Okay. Let me write few more terms. 5, C5, next C. All these are the terms of the sequence. Now let us write in closed form. What is C1? C1 means first term of the sequence by substituting n is 1. Now substitute here n is 1. N is equal to 1 means odd number or even number. N is 1. N is 1 is odd number. So if it is odd number, value is 1 by n. If it is even number, value is minus 1 by n. So now n is equal to 1 is odd number, first term. So therefore 1 by n. 1 by n means 1 by 1. N means 1 means first term. Next, n is equal to 2 you are substituting, then you will get C2. N is equal to 2. 2 means even number. N is 2 is even number. Then choose minus 1 by n. Then minus 1 by n is 2. Like this. Now third term, that means n is 3. N is 3. 3 is odd number. Then 1 by n. That means 1 by 3. Like this. Next, n is equal to 4. 4 is even number. So minus 1 by 4. Next, n is equal to 5. Odd number. Odd number means it is 1 by n. So 1 by 5. Like this. Now n is equal to 6. Even number. Even number means minus 1 by 6. Next, n is 7. Odd number. 1 by 7. Like this. N is 8. Even number. Minus 1 by 8. Like this. So like this. So these are the terms of the sequence. So now this is sequence Cn. So this is how to generate terms of the sequence. This is just basics I am telling. In the next class I will explain in brief. Now let us do some problems. Find a formula, okay, for the nth term. Here nth term we need to construct of the given sequences. I require nth term. What is the nth term of the sequence? So let us take the first one. Indirectly, nth term or formula or order, whatever. Nth term or order or rule, sorry. Nth term or rule or formula whatever. Nth term or rule or formula. Now let us find the nth term or rule or formula. So now the given sequence is, how I am getting, What are the terms of the sequence? 1, 4, 9, 16, right? 25 and 36 up to so on. So these are the terms of the sequence. That means indirectly first term a1 is 1, okay, and a2 is 4, a3 is 9, right? Next a4 is 16, okay, and a5 is 25, right? Now a6 is 36. Look at, and up to so on. Now what should be an? This is question mark actually. Simply you have to observe all these terms, okay, then you choose proper n. So now I am choosing by observation simply, therefore an is equal to n square by observation only. If I substitute n is equal to 1, what is a1? 1 square is 1. Look at, if n is equal to 2, a2 value is 2 square 4 I am getting. Look at, now n is 3, n is 3, 3 square is 9. Look at, so therefore clearly by observation only. So there is no formula, or there is no some particular technique for finding nth term, simply by observations. So if you choose for example n square plus 1, let us write n square plus 1, or n cube, let us choose n cube for example. If I choose n cube, if I substitute n is equal to 1, 1 cube 1, first term I am getting, but second term I am not getting, n is equal to 2. If I substitute n is equal to 2 here, it will be 8, but my second term is 4, therefore this is not my formula or rule or nth term. So accordingly you have to choose the particular nth term or rule, particular formula. So therefore here the sequence is n square. Therefore the final answer is for this, the nth term, therefore an is nothing but sequence n square. That's it. So therefore an is n square, because nth term we need to complete. Similarly for the second one, so likewise you have to observe second 0, 3, 8, 15, next 24, and up to so on. Just you have to think, while if you substitute n is equal to 1, so you will get a1, that will be 0. If you substitute n is equal to 2, that means a2, that will be 3. If you substitute 3, that is a3, which is 8. Then accordingly you have to choose the nth term, okay. If you substitute n is equal to 4, a4, which is 15. If you substitute n is equal to 5, a5, which is 24. Then similarly, therefore what is an? This is question mark actually, up to so on. Okay, so now, so then again same story, you have to think, you have to keep on verify. If I choose an is if I substitute 1, I should get 0. Then if I write n minus 1, does it work out? If I substitute n is equal to 1, 1 minus 1 0, it's okay. But what about second term? Substitute n is 2, 2 minus 1 1, but I am getting 3. So therefore this is not correct. So like that you keep on verify. Can I do n square minus 1? Substitute once. N is 1. N is 1. 1 square minus 1 is 0. Okay, perfect. N is 2. 4 minus 1 3. Yeah, perfect. N is 3. 9 minus 1 8. 16 minus 1 15. Next 25 minus 1 24. Perfectly it is working out. So therefore this will be the formula, required formula. Therefore the sequence an is simply n square minus 1. You have to write the sequence in plural brackets like this. You can write n is equal 1 to infinity, or you can write like this, no problem. So therefore what is an now? Nth term is simply n square minus 1. N square minus 1 will be the formula. According to this formula, all these terms are arranged. Similarly, you can look at third one. Can you guess? 1 3 1 3 1 3. So now third one, yeah, 1 3 1 3 1 3, and up to so on. Can you guess now? So here a1 is 1, right, and a2 is 3, second term is 3, a3 is 1 again, okay, and what is a4? A4 is 3, okay, like that. So a5 is 1, okay, and a6 is 3, so like that up to so on. Then what is an is question mark, and what is nth term, okay. Now let us think of it. So if I choose n like this, so look at when a1 is 1 and a3 is 1 and a5 is 1. So if n is odd, so I'm constructing like this. So 1 if n is odd number, n is odd number, if n is odd, and 3, right? 3 if n is even. You can construct like this if n is even. That's it. So this is a formula. This is one way of doing. Or you can write like this also. One more. Can you give one more formula for an nth term? N. So if I substitute 1, I should get 1. Substitute 2, I should get 3. So then let me write 2 plus minus 1 whole to the power of n. Let me write like this. 2 minus 1 whole to the power of n. Let me write it clearly. This is minus 1. Okay. So minus 1. So 2 minus 1 whole to the power of n. Now, let us write what is n is 1. Substitute n is 1. N is 1 means a1, right? You are getting 1. Okay. Now n is 2. Substitute 2 minus 1 whole square is 1, which is 3. Now n is 3, 1, right? Because it is minus 1, 2 minus 1, 1. Now n is 4, it will be 3. Look at perfectly all right, right? So therefore you can take this one or the above one as a nth formula, nth term formula. Now what is f5? It is 1. Now a6, it is 3. So perfectly all right up to so. So either you can take this one as an nth term formula, or you can take this one as a nth term formula, your wish. Both are true in this case. See here, nth term formula is not unique. You can construct like this. See, whatever the formula, simply you have to get the terms of the sequence by using that formula. Then that is called nth term formula. For example, sometimes first 5 terms you will get perfectly, but after that 6 term onwards you will not get. Then you should not use that one as a nth term formula. Each and every term you should get by using that term. Then that is called nth term formula. Okay, so this is about construction of terms of a sequence by using nth term formula. Next one, recursive definitions. So one more type of sequences. How to construct these sequences? Look at, sequences are often defined recursively by giving the value of the initial term, or terms, and a rule. So one initial term should be given and one rule is given, rule or formula, whatever. Then such a sequence are called recursion, or such a terms are called recursion formula for calculating any later terms from terms that precede it. Look at some examples. Example number 3, how to construct such recursive sequences. First one, look at this. So in this, a1 is 1 is given. So this is called initial term. So this is initial term. Okay, initial term according to definition. This is initial term. Only one term is given. Sometimes two terms will be given, like a1 and a2. That's why here initial term or terms I have mentioned. And one rule should be given, compulsory, a rule. So this is called rule. This is rule. Okay. If a statement having initial term and a rule, such a sequence is called constructive recursive sequence. Recursive sequence. Okay, this is a recursive sequence now. Now how to define the sequence? Now look at, since the term an is present here, then you can construct like this. So an, now run sequence. So n is equal to 1 now. If n is equal to 1, a1, n is equal to 2, a2, n is equal to 3, a3, n is equal to 4, a4, n is equal to 5, a5, n is equal to 6, a6, and up to so on. All these are the terms of the infinite sequence. What is a1? a1 is 1. Now a2 is not given. From a2 onwards you have to use this formula. This formula you have to use. Then you have to construct the remaining terms. Because that's why this is n more than or equals to 2. That means n is equal to 2 onwards. N is equal to 2 onwards means from second term onwards. All these terms you can generate by using this rule. Now let us generate all those terms. So clearly, yeah. So given that a1 is 1, right? So by using this, let us construct what is a2. A2 we need to construct, right? A2 is question mark. Now what is given to us? An minus 1. So this is a rule of the recursive sequence. An minus 1 is equal to n plus 2. Okay. Now n is equal to 2 is substitute. So 2 minus 1. Let me write this very clearly. Let me write here. N is equal to 2 first. N is equal to 2. N is equal to 2. This will be a 2 minus 1. 1. This is n is equal to 2. A 2 minus 1. 1. And 2 plus 2. N is equal to 2 you have to substitute, which is nothing but, what is this? 4. Initial term already given, then n is equal to 2, don't substitute, you substitute from 3. So therefore this is n is equal to 3 you write. Yeah, this is 3. From 3 onwards, n is equal to 3. Okay. Then from 3 onwards you have to substitute this. So therefore n is equal to 3. Substitute n is equal to 3. Now you are getting a2. Substitute here. 3 minus 1 is 2. a2. Now n is 3. So 3 plus 2, which is 5. Okay. So therefore this is 5. Yeah, 5. Next n is equal to 4. If you substitute n is equal to 4, substitute here 4 minus 1 3. So a3 you are getting. Because already a1 you are having, a2 we completed just now. Next a3. Now n is 4, a3. Substitute here in this formula only. So this is a formula. In this formula you have to substitute all those indexes. Okay. And now n is 4 you substitute here. Then we will get a3. N is 4. 4 plus 2. 4 plus 2, 6. Okay. Next one, n is equal to 5. Substitute n is 5. Then what will you get? If n is 5, you will get, substitute n is 5 here. 5 minus 1, 4. So a4 is equal to 5 plus 2. 5 plus 2, which is 7. Is 7. Now n is 6. Substitute n is 6 in this recursive formula. N minus 1, 6 minus 1. So a5 is equal to 6 plus 2. 6 plus 2, which is 8. So up to so on. So therefore the sequence an is, so therefore let me write that sequence an is, so sequence an is, a1 is the first term, a2 is the second term, a3 is the third term, a4 is the fourth term, and up to fifth term, and up to, yeah, a1 is 1 because this is initial term. What is a2? a2 are computed as 5. Now a3 is 6, a4 is 7. Okay, a5 is 8, and up to so on. That's it. So this is recursive sequence. Recursive sequence means it should be having some initial terms and a rule or a formula. So this is example of a recursive sequence. Similar second example, look at the statement a1 is given. That means this is initial term is given, initial term, and this is a rule. This is a rule. This is a rule, and this is initial term. Initial term. Okay, now let us construct. So sequence an, which is a1, a2, a3, a4, up to so on, right? Now, so let us find remaining terms. So a1 is 1 is given to us. Now an, so the rule is an is equals to n into a n minus 1 into a n minus 1. That's it. So according to this rule, let us construct the remaining required terms in the sequence. Okay, now let us write. First n is equal to 2. Substitute n is equal to 2 here, I will get second term. So now substitute in this formula, a2 is equal to, n is equal to 2 is substitute, 2 into n is equal to 2, a 2 minus 1, 1, 2 into a1. So 2 into, what is a1? a1 is 1 only. 2 into 1, which is 2. Therefore a2 is 2. Similarly n is equal to 3. N is equal to 3. Then we will get, substitute here n is 3. We will get a3. a3 is equal to, n is 3. 3 into, substitute n is 3. 3 minus 1, 2. So a2. So 3 into a2. So 3 into what is a2 here? a2 value is 2. So substitute here 2. Now you will get 6. So this is a3. Similarly, n is 4. Okay. Now n is 4. So substitute n is 4 here. So a4 is equals to n is 4 here. 4 into, right? 4 into n is 4. So a3. Now this is 4 into what is a3? a3 is 6, which is 24. 24. Similarly, n is 5 and up to so on. So n is 5. So that is a5. a5 is equal to 5 into a4. Okay. So 5 into 24. Okay. So this is 120. 5 4s are 20, 0, 2, 5 to the 10 plus 2, 12, 120. So like that you can construct. So up to so on I am writing, up to so on. So therefore now the sequence is, so therefore the sequence an is, so a1, a2, a3, a4, okay, a5 and up to so on. So now what is this? What is a1 now? a1 is given already initial term, which is 1, and a2 we computed, which is 2, and a3 is 6, and a4 which is 24, and a5 which is 120, up to so on. So this is recursive sequence second example. Similarly, the third one, look at here. What is given? Here two terms are given, initial terms. So these two are initial terms. Okay, initial terms. And this is, what is this? It is a formula or rule or nth term, n plus 1th term, whatever, n plus 1th term. So now let us construct the sequence. Now what is sequence an? That means a1, a2. Now n is 1 to infinity, right? N is equal to 1 to infinity, then n is equal to 1, n is equal to up to so n is equal to infinity, how to do that? So if you substitute n is 3, you will get a3, n is equal to 4, you will get a4, and up to so on infinity terms. Okay. Now here what is given to us? a1, a2 are given already. Okay. So a1 is given, which is 1, and a2 also given, which is 1. So two initial terms are given. So a3 onwards we want. So let us use this formula. An plus 1 is equals to an plus an minus 1. So use this formula, then you get the remaining terms. Now let us substitute. I want a3 onwards. a3 means n is equal to 2, you have to substitute here. That's why here 2 onwards. N is equal to 2 onwards. Now substitute n is 2. Yeah, let us construct now. N is equal to 2 now. If you substitute n is 2 here, you will get a3. In this I am substituting, in this formula. This is a formula, okay? Or rule, whatever. N is 2 is substitute, you will get a3. LHS side, RHS side, substitute n is 2 here. N is 2, a2 plus n is 2, 2 minus 1, 1, so a1. Indirectly sum of previous terms. a3, how to get a1 plus a2? Sum of two previous terms, preceding terms, whatever. So now a2 is 1, a1 is 1. 1 plus 1, 2. So therefore a3 is 2 now. Next n is 3 you substitute. So substitute n is 3. Now what will you get? N is 3. In the formula or rule you substitute what is meant by n is 3. So n is 3. Here you substitute n is 3. Then you get a4. 3 plus 1 is 4. N is 3. a3 plus n is 3. 3 minus 1, 2. So a2. Look at again. How to get a4? Sum of two preceding terms, a2 plus a3. Now what is a3 now? a3 value is 2, just now we computed. Plus what is a2 value? It is initial value, which is 1. That means 3. So now n is equal to 4. Right. So then substitute in the formula. N is 4, a5. a5 is equal to, substitute n is 4. a4 plus n is 4 here. 4 minus 1, 3. So a3. Right. Which is, now what is a4? a4 is 3 plus a3. a3 is 2. 3 plus 2 is 5. Okay. Similarly, n is 5. N is 5. That means a6 is equals to a5 plus a4. a5 plus a4. Sum of two preceding terms. Yes, what is a5? a5 is 5 plus what is a4? a4 is 3, 8. So therefore up to so on. So therefore now the sequence is, so therefore sequence an is, what is a1 now? a1 is 1, a2 is 1. What is the next term? Sum of two preceding terms. 1 plus 1, 2. Next 2 plus 1, 3. Next 3 plus 2, 5. Next 5 plus 3, 8. Can you guess next term? 8 plus 5, 13. 13 plus 8, 21. Next 21 plus 13, 34. Next can generate so on like that. Okay. So the sequence having some particular name, uh, that is called Fibonacci sequence. Fibonacci sequence. Fibonacci sequence. Particularly this sequence, a special sequence. The importance of this sequence we will get into now in higher classes. There is a particular sequence that is called Fibonacci sequence. Sequence name is Fibonacci. In some, you can write like this also. It is not, the Fibonacci sequence is not unique. Actually, the original meaning of Fibonacci sequence is the next term is the sum of the two preceding terms. That is called Fibonacci sequence. If you start like this, for example, look at this. If you start like this, if you choose a1 is 0 and a2 is 1, and rule is an plus 1 is equal to an plus an minus 1, an minus 1. Then according to this, can you generate the sequence now? So a1 is 0, okay, 0, and a1 is 1, a2 is 1, a2 is 1. Now what is a3? a3 is nothing but substitute n is 2 here, n is 2, a2 plus a1, a2 plus a1. What is a2 plus a1? 0 plus 1 is 1. Now what is a4? a4 is nothing but a4 plus a3, sorry, a3 plus a2, a3 plus a2, sum of two preceding terms. What is a3? 1. What is a2? 1. 1 plus 1, 2. Similarly, what is a5? a5 is nothing but a4 plus a3, a4 plus a3. This is nothing but 2 plus 1, which is 3. Okay. Now a6 is nothing but a5 plus a4. According to same, in this formula only I am substituting. N is equal to 5 I am substituting. Then a6 is equal to a5 plus a4. What is this value? What is a5? a5 is 3 plus a4 is 2. Now 5. Look at same numbers only I am getting. 1, 2, 3, 5. Look at 1, 2, 3, 5. But starting with here 0. So now what is the sequence here in this? So therefore sequence an is first two initial terms a1 0, a2 1, a3 1. Next 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8. Same sequence only. It is also a Fibonacci sequence. Okay. Initial term here is 0, but here initial term is 1. That's it. These two are Fibonacci sequences. Either you can start with 0 or you can start with 1. Both are Fibonacci sequences. Okay, this is a special sequence. Next one, concept convergence and divergence. So sometimes the numbers in a sequence means what? Collection of numbers according to some order or some rule or some formula. Okay, so the numbers in a sequence approach a single value as the index increases. Okay, what do you mean by this? I will explain. Look at examples. First one, 1 by n. Let us consider this sequence. Now in this sequence, let us write the terms first. If n is 1, we will get 1. If n is 2, we will get 1 by 2. If n is 3, we will get 1 by 3. If n is 4, we will get 1 by 4. Start with 1 because sequence is a function from where to where? It is a function from natural number set to real number system. That's why you have to start with 1 only, because natural numbers start with 1. That's why n is equal to 1 I am substituting. Okay. So n is 1, 1 by 1, 1. N is 2, 1 by 2. N is 3, 1 by 3. N is 4, 1 by 4 like that. 1 by 5 like this. So this is a sequence. Okay. Now look at now. Sometimes, not always, sometimes the numbers in a sequence, that means these numbers 1, 1 by 2, 1 by 3, 1 by 3, the numbers in a sequence approaches a single value as the index increases. Index means what? N is an index, right? So an, if an is a sequence, so this n is called index, this n is called index. If n is increases, increases, n is 1, n is 2, n is 3, n is 4, n is 5. So now up to so on, what is the last value of n? That means infinity, it's a large number, right? If you substitute large number, let's say infinity, n is infinity, then what is the value 1 by infinity? 0. So as n increases, the sequence reach to or approach to 0. Approaching, that means the sequence approaching to 0. Similarly, here, what is this? It is nothing but 1 minus 1 by n, right? Simplify this. N by n minus 1 by n. Now substitute n is 1. N is 1, you will get 0. N is 2. N is 2. 1 minus half is half. Now n is 3. 1 by 3. So 2 by 3. Right? N is 4. 1 minus 1 by 4. So 3 by 4. Isn't it? N is 4 is substitute. Next n is 5. 5 means 4 by 5. So up to so on. Now as n increases, that means n is large. If n is large, let's say infinity, large number infinity. Now 1 by infinity is 0. So 1 minus 0 is 1. So this sequence approaches to single number 0. This is single number 0. That's what it's telling. Sometimes the numbers in a sequence approach a single value as the index increases. And now this one, what are the terms? 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, and up to so on. Now can you guess the sequence approaches to which number? That is infinity. As n is very large, let's say infinity. Infinity square is infinity only. Now this is approaching to infinity. What is this? N is 1 minus 1. N is 2 plus 1. N is 3 minus 1 plus 1 minus 1 plus 1 minus 1, like this. Can you guess what could be the now can you guess at what number the sequence approach as n becomes large number? But before going to the large number, you need to know what is that large number. If the large number is even number, then this will be 1. If the large number is odd number, then this will be minus 1. So the final value is here, this is plus or minus 1, but which one particularly, if plus 1 or minus 1, we don't know. Particularly which one we don't know. So now this one we cannot tell. That's why sometimes I'm telling here, sometimes we can know. Sometimes the number in a sequence approach a single value, but here it is not approaching single value, it is approaching two values, because we don't know what is that large number. That large number may be infinity, that large number may be even number, may be odd number. So you are unable to tell to which number this sequence approach. It is not approaching to single number. Understood? So based on this, now look at one formal definition of convergence and divergence. Look at this. The sequence, listen carefully, it's very important. The sequence of real numbers an or n is equal to 1 to infinity, whatever, both are correct in symbolic form. So the sequence of real numbers converges to a number L. Converges to number L. If for every epsilon greater than 0, there exists a natural number n such that modulus of an minus L should less than epsilon for all n more than or equals to n. Don't worry about all these notations and all these things. I will explain carefully. So now we say that the sequence diverges if no such number L exists. Some single number L exists. If the sequence converges to L, then we write limit n tends to infinity, nth term of the sequence will be L, or that sequence is reaching to L. Just now I told you, right? 1 by n is reaching to 0. 0 is a single number, that 0 is nothing but here L. So look at this, 1 by n is a nth term of the sequence, an you write, this is nth term of the sequence. So if you write like this, this is nth term of the sequence. But if you write like this is called sequence now. This is sequence 1 by n, you have to read like this. This is sequence 1 by n, this is nth term 1 by n. Know the difference between these two, okay? Sequence 1 by n, this is nth term 1 by n. Now look at an is approaching to 0, right? As n tending to infinity. Substitute n is equal to infinity here. 1 by infinity is 0. So now this is L. This is L here. N is approaching to 0. nth term is approaching to L as n becomes large. Similarly, indirectly you can write this one as, how can I write? So limit for that particular 1 by n tends to infinity, an is nothing but limit n tends to infinity, an is 1 by n. Now what is this? So which will be 0. Look at the same thing. The limit n tends to infinity, an is L. So here this is L now. So this is L now. Single number L. Okay. If such number L is existing, which is finite, then I can say that the sequence is converges. Sequence is converges. If such number L not existing, if no such number L exists, then the sequence is called diverges. Two sequences, converges sequences and diverges sequences. Simply remember like this. If a sequence converging to a single finite number, like this sequence 1 by n, then you can call this sequence as converges sequence. If the sequence is not approaching to single number L, then the sequence is diverges sequence, or sequence is diverging. That's it. Now you look at in symbolic form, what is mean by this one? An minus L is less than epsilon. See, take that one separately. Note what is mean by this epsilon and n more than or equals to n and what, all these things. Look at now. So it means an minus L, modulus of an minus L is less than epsilon. Okay, for all n is more than or equals to some capital N. See, remember it is not natural number. Natural number I can denote like this. This is natural number. Just I'm writing capital N. You can call this one as capital N. This one is natural number set. Okay. Yeah. Now you expand this modulus. If you remove this modulus, you will get minus epsilon less than an minus L less than epsilon. Now add L to both sides. So L minus epsilon less than an less than L plus epsilon. Indirectly I can say that therefore an belongs to open set L minus epsilon to L plus epsilon indirectly. Yes or no? an is lying, this nth term is lying in which interval? L minus epsilon to L plus epsilon. If you look at graphically, okay, let's call for example this number is L. Sequence is converging to L. Epsilon is some finite number. Whatever the number epsilon you can take. Okay, now epsilon is a small number, then what is L plus epsilon? L plus epsilon will be after L, right? It is more than L. So assume this is L plus epsilon. L minus epsilon means it is before L. Let's call this is L minus epsilon. L minus epsilon. Now, so this is the interval n minus epsilon to L plus epsilon. Now L is the middle one. Okay. Now what is meant by this? Its meaning is for all n more than or equals to, for all n more than or equals to n. Listen carefully. Note this one. It is just a capital N. Okay. Just a capital N. What is this capital N? Look at it in the definition. There exists a natural number set, natural number n. After that natural number, all the terms will be in this interval. Okay. Now, for example, let's say n is equal to, for example, n is equal to 4. If n is equal to 4, what is mean by this? N more than or equals to 4, right? Indirectly, n more than or equals to 4 means what? N is 5, 4 onwards. N is 4, n is 5, n is 6, like that. That means what? N is 4, n is 5, n is 6, n is 7. How many terms? Up to so on. So these are infinitely many terms. So infinitely many terms are lying in this interval, indirect meaning. Okay, ans are belongs to this interval. But what are ans? What kind of ans? N is more than some particular n. This there exists a natural number n. That n natural number is, if you take 4, then 4 onwards infinitely many terms lies in this interval. But what are these terms? These are the sequence terms. What is sequence? Sequence is, here is an. An is a sequence. An is a sequence. How many terms? The sequence having infinitely many terms. A1, A2, A3, A4, up to so on. Let's write A5, A6, A7, and up to so on. In this, from fourth term onwards, all these terms are lying in this interval. If you choose n is equal to some 7, for example, if n is equal to 7, then A7, A8, A9, up to so on. Again, infinitely many terms are lying in this interval. Choose n is equal to 20, for example, capital N is 20. Now, A20, A21, A22, A23 up to so on, last up to large numbers, large number of terms. Again, those are lying in this interval. So indirectly what I'm telling you is, if a sequence is converges, then infinitely many terms should lie in this interval. If a sequence is diverges, infinitely many terms of the sequence does not lie in this interval. So that is the meaning of this one, an minus l less than epsilon. Its meaning is infinitely many terms of the sequence will lie in the interval of l minus epsilon to l plus epsilon. Epsilon can be any number. Look at here, a number l if for every epsilon more than 0. Particularly, let me explain with one example, then you understand very clearly. Let us take one example and let's take the sequence an only. Familiar sequence an, which is 1 by n, 1 by n. Let us take this sequence. Okay. Now, does it converges? Let us verify now. So, limit n tends to infinity an, right? Now, what is this? So, limit n tends to infinity. Now, what is an here? An is 1 by n. Now, this answer is 0. So, now this is like L. This is L now. It is converging to a single number. Therefore, this is converges sequence. Converges sequence. The sequence is converges. Okay, this is converges. But what is mean by this? Look at by epsilon definition. See here L is 0. Okay, and what is an? An is 1 by n. Okay, now let me write the sequence an. Sequence an. That means substitute 1, you will get its meaning is what? An, which is 1 by n. Now the terms are 1, 1 by 2, 1 by 3. Okay, next 1 by 4, right? 1 by 5, 1 by 6, 1 by 7, 1 by 8, 1 by 9. Let me write more terms. By 10, 1 by 11, 1 by 12, 1 by 13, and up to so on. Okay, 1 by 13 and up to so on. Okay, let me write in decimals. Up to so on. Yeah. So in decimals, what is this? So 1, this is 0.5. Okay, and 0.33 and up to so on, and 0.25. Okay, and 0.02. Okay, and 0.0769. 1 by 13 means, okay, and up to so on. Okay, so now let us go to the definition. So according to convergence sequence, an belongs to l minus epsilon to l plus epsilon. L plus epsilon. Okay, l minus epsilon to l plus epsilon, right? L plus epsilon. This is true for all n more than some n, capital N. That means infinite many terms lies in this interval. Now here what is L now? L is 0. Okay, converging to 0. So therefore 0 minus epsilon to 0 plus epsilon. This is true for all n more than capital N, more than or equals to capital N, or more than whatever. Now an belongs to minus epsilon to plus epsilon. Now epsilon is for all epsilon, right? You look at the definition, all epsilon. So let's choose epsilon is some. So let epsilon is equal to, let us say some 0.5. If epsilon is 0.5, then what is an? An belongs to minus 0.5 to plus 0.5. Yes sir. Substitute epsilon is 0.5. What does it mean? For all n more than capital N, more than or equals to capital N. Now in this, how many terms? Remember, how many terms? Listen carefully. How many terms lies in this interval? Does the first term lies? No. 1 does not lie. Second term? No, because it is open interval. Okay. Third number? Yes, it lies. Third number lies. Fourth number lies. Fifth number lies. Sixth number lies. Seventh number lies. Eighth number lies. Look at. So from third number onwards, that means now here capital N is 3. I think you understood now. That means for all n more than or equals to 3. So third term onwards, all the numbers, but how many numbers? Infinitely many numbers lying in this interval. Therefore, the sequence converges. If infinitely many numbers lying in particular interval, then the sequence converges to center of that interval. What is center? 0. It converges to 0. If infinitely many terms are not lying in that interval, then it is divergent sequence. See, remember, whatever epsilon you have to choose, the concept has to be true for all epsilon. See, for example, if I choose, you can choose what is the number. Let epsilon is some, let's say, 0.01. Let's say 0.01. Now, what is it? Now, what is interval an belongs to? Minus 0.01 to plus 0.01. Okay. Now here third term also does not lies. Fourth term no. Fifth term no. Sixth term no. Seventh term no. Eighth term no. Ninth term onwards lies. And ninth term also no. Sorry. 10th term no again. 11th term no. 12th term no. 13th because it is 0.07. It is 0.01 only. It is 7th term. So which term it is? 13th term. 13th term no. Like that you keep on verifying. 14, 15, 16, 17, 18, 20. What is 1 by 20 value? 1 by 20. Which is 0.05. 0.05. Does it lies here? It again it is not, right? 0.05. Next 1 by 30. 1 by 100. This is 100th term, right? Subset n is 100, 0.0. What? 0. Is it? Now what will you get? 5. So again this lies here. So therefore from here onwards, a 100. So 100th term. So 101 term onwards. So therefore capital N is 101. 101. So for all n more than or equals to 101. So 101 term onwards, 101, 102, 103, 104, 105, 106, 107 up to so on infinity. So that many terms are lying in this interval. Again, infinitely many terms are lying. If you choose epsilon is some 0.30, let us choose epsilon is 0.30. Another one. Okay. Now let us choose epsilon is this. Epsilon is 0.30. Then what is the interval now? Interval is an belongs to minus 0.30 to plus 0.30. Okay, now look at how many points are lies. 3.0830. So this a1 does not lies, a2 does not lies, a3 does not lies. Look at this lies. So a4 onwards. Therefore now for all n more than or equals to 4. So here capital N is 4 now. There exists a capital N. Compulsory there exists n. That means for which term onwards the terms are lying. So this is the hidden meaning of a convergence of a sequence. If the sequences converges, definitely this phenomena work out. If the sequences diverges, this phenomena cannot work out. That means only for one epsilon it may be true, but it cannot be true for all epsilon. If whatever the epsilon you choose, if it is true for whatever the epsilon, then the sequences converges. So this is the meaning of hidden meaning of convergence of a sequence. And with this I will stop and I will continue in next class with a few more examples.